What's up, everybody? Professor Calderon here. So I got my replacement phone. I dropped the first one in the swimming pool. That was a bummer. It's freezing cold. Our pool is not heated. I thought I was going to go into hypothermia just trying to get it out. It was crazy. Anyway, got a replacement. Get insurance on your phone or a waterproof case, or just don't clean the pool with your phone in your pocket. So anyway, what I decided to do is just do a straight review session with the questions, the real questions that are on the test. And I'm going to give you the question and then give you the answer, I guess. Yeah, I guess that's what I'm doing. Anyway, here we go. There's only 20 questions. There's one question that has to do with American Beauty, so that's the only one I'm not going to give you. You will have to watch American Beauty to get that question, to answer that question. That's the only thing. So the first question is, line, as discussed by Bruce Block, is are perceptual facts. Line, as discussed by Bruce Block, are perceptual facts. This question is indeed true. Lines are perceptual facts on film because we don't actually see them on film. Like this line right here, right? This one right, let's see, right there in the wall. Or this line making the square on the speaker. We don't actually see those. For you guys, it's a perceptual fact on the screen space. So that answer would be true. The next question. Hot colors appear to advance or exist closer to the audience. Hot colors appear to advance or exist closer to the audience. This is true. And the rule is hot colors appear to advance, cold colors recede. Our hot colors are our reds and our yellows, and our cold colors are our blues and our greens. So that's the easiest way to remember this rule. Hot colors advance, cold colors recede. Hot colors advance, cold colors recede. So this answer is, again, true. The next one is, tone has to do with low frequency and color spectrum. Check, check. All right, so I'm back. I don't know what happened. Phone cut out. Siri thought I was talking to her. So anyway, so the next question is, tone has to do with low end frequency of the color spectrum. That is false. Tone, if you remember from the book, has to only do with the brightness of an object on the color scale. So it's the gray scale, that going from darkness to brightness. So that would be false. The next question, when objects on the screen do not overlap, right? Do not overlap. We translate that into, I gotta actually click on this one. We translate that as a deep space cube. Okay, so this is false, and let me show you why. All right, here I have two objects. If they do not overlap, right, like this, we do not translate that as a deep space cube. Because when they do overlap, right, when we do have overlap, the only way they can overlap is if they exist in a third dimension so that they can miss each other on a different plane, like that or like this, right? So when we see them where they do not overlap, when objects do not overlap, that sort of translates as a flat space cube, okay? Moving on to the next question. Okay, the next question, what causes aerial diffusion? And this is a multiple choice question, okay? I'm not even gonna look at it. I don't need to know the answers. This is easy. there are only two types of aerial diffusion. There's like aerial diffusion and there's textural diffusion. Textural diffusion is just caused by the natural distance between things. You know, as objects are farther away, they have less detail. Aerial, the word aerial, right, meaning air, cues us off that it has to do with something in the air. So aerial diffusion is caused by objects, particles of something suspended in the air, like smoke or rain or falling rain, something that's shading the air and it's reflecting that light off of it. That's causing aerial diffusion. The next question, objects of unknown size. Objects of unknown size that are larger on the screen appear closer. Objects of unknown size that are smaller on the screen appear farther away. True or false? That would be true. If we have two objects of unknown size, like, let's say, these mints. Boom, I got two mints right here. They're both the same size, all right? Now one appears smaller because it's farther away, and vice versa, all right? So we have two objects of unknown size, all right? When it appears larger, it appears closer. When it appears smaller, it appears farther away. Boom. So that would be true. The next one. This photo is an example of a three-point perspective. And I have to actually view. For some reason. I'm going to come back to this one because for some reason the image is not coming up. The next one is vanishing point is a deep space cube. We all know what a vanishing point is, right? It's that little point off in the horizon where it appears that two parallel lines connect. And we know they don't actually connect because they're parallel lines. And by law, two parallel lines cannot connect. They can run forever and ever and ever and never touch. But if we see two parallel lines, like if we're standing on the railroad tracks, it will appear, and looking at up the tracks, it appears that the tracks will connect off in the horizon. We call that the vanishing point. Okay? And that gives us a deep space cube. So this would be true. Next question. Ambiguous space is when the viewer sees what is on the screen. And make sure I read the question properly. Ambiguous space is when the viewer sees what is on the screen, but the colors are reversed to obscure the size of the image. Okay, this question, let's think about what is ambiguous space. Ambiguous space is simply an image that we can't discern what's going on. We have no cues into space, size, or anything. It's ambiguous. And like he talks about in the book, it's very hard to hold because the mind is always trying to pick out little clues and figure out what the heck it's looking at. So, ambiguous space is not only when the colors are reversed. No. Reversing colors has nothing to do with ambiguous space, although you can reverse colors and still have ambiguous space, right? It's not the colors that's obscuring the image. It could be a combination of anything that's obscuring it, okay? weird lines, shadows, just completely dark image, right? So this answer would be false. Moving on to the next one. A single frontal plane in itself is adequate to create limited space. This answer is false because limited space is a combination of both deep and flat space cues. Okay? So the frontal plane in itself is only half of the equation. The frontal plane is going to give us a flat space cue. We also need another deep space cue along with it. Either size difference, or maybe someone's reversed, size difference, or someone using color, hot and cold. So limited space is the combination of both deep and flat in the same frame. So this answer would be false. Because limited space is a combination of both deep and flat together. Okay, reflective control is about controlling the brightness via paints, pigments, dyes of the objects in a set. That would be true because we are reflecting colors off of pigment. They are absorbing light, like dyes, paints on the wall, the colors of objects on the set. This computer, the plastic in it has pigments in it. And what those pigments are doing, the reason why it looks blue to us is because there's a certain, when the light hits it, it's absorbing a certain color spectrum, the red, and reflecting the blue. And our eyes picked up the blue. So in film, that's one of the ways we can control the color of a film. We can have the color look of a film. We can have everyone wearing the same color. And that would be reflective control. So this would be true. Moving along here. The next question. If a stationary camera does a pan, does it maintain deep space? If a stationary camera does a pan, it maintains deep space. So he's like I didn't write this, right? I'm making a statement here, and I want you to tell me if this statement is true or false. A stationary camera does a pan, it will maintain deep space. Okay, so let's say this flashlight is the camera lens going that way. All right, and here's the pan. So as it pans, everything will appear on the lens to move evenly across the frame, just like I'm doing now. So when things move evenly across the frame, we do not get that relative movement, right? We don't get things moving faster, one moving faster than the other. So this answer would be false. It does not maintain deep space because deep space is accentuated by relative movement, right? If we took the camera off the axis and rolled it around the room, that would be a different look. Okay, we would be accentuating deep space. So this answer would be false. This statement is false. The audience's attention is drawn to visible vanishing points. So remember what that vanishing point is, that little dot on the screen that isn't there, that we kind of see it as there, even though it doesn't exist. It's a perception, a fact of perception. It doesn't exist really. And our mind is sort of drawing the lines there. So if our mind is drawing the lines there and it's not even there, of course, yes, this is true. We are drawn visually to those vanishing points. So this question would definitely be true. All right. So the next one is vanishing points. Where are we? Next one is easier. It's easy. Red is a cold color. As I stated in the earlier video, our hot colors are reds, yellows, and anything like that. Our cool colors are the blues and the greens. So yes, red is a hot color, not a cold color. So this answer would be false. Our next question is staging objects in the foreground, midground, and background will create flat space. Let's think about that. The foreground is closer. The midground is halfway between the foreground and objects far, far, far in the back. So if we are putting objects on all three planes, we're going to get relative size difference. We're also going to get textural diffusion because the objects from far, far, far away are going to have less texture, right, than the objects closer where you can see all the texture. So, wow, even right there in my shirt, right? So this statement, staging objects in the foreground, midground, and background will create flat space, is 100% absolutely false. Okay, it's going to accentuate and create the perception of deep space. Next question. Blurred objects eliminate depth. Blurred objects eliminate depth. So when we have a blurred object, we do not have detail. Right? We don't see the texture of that object. It's kind of just a blur. And in real life, when objects are sort of blurred out and we don't get the texture, that's usually because it's far, 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 far away, and we just can't focus that well on the detail. So this answer would be true. Wow. Looks like the music was right on cue, right? So that answer would be true. The next one is objects closer to the top of the screen appear farther away. Okay, so this is the up and down rule, or the rule dealing with the up and down position. Objects higher up in the screen appear farther away than objects lower in the screen. And actually, that is the rule. So, yes, this is true. In the book, he says, word for word, objects closer to the top of the screen appear farther away than objects lower in the screen. It's the rule of the up and down position, and it's true. So, next one. A visual progression is when they put a camera on a dolly and move it. A visual progression is not when we put a camera on a dolly and move it, although it does sound very convincing because we think progression, we think movement, but this statement is absolutely 100% false. A visual progression is a series of images that change from one thing to the next as it goes from image to image to image to image. So this answer would be false. Booyah. And the next one is depth cues. Depth cues create the illusion of deep space. Yeah, that's what we've been studying for all these weeks, the depth cues. And when we have depth cues, yes, we do get the illusion of deep space. So that's another thing that was lifted straight out the book. Hopefully you saw that one. And yes, the DJ is still right on point. I don't know if you guys can hear this. I'm rocking some old school beats. What's the next one? Okay, that's it. The last question is a bonus question, and that is going to come from the film American Beauty. I hope you watched it. That one multiple choice question. Where is it? Is this an example of 3-point perspective? How will I handle that one? Okay, here we go. The way we know what perspective we're looking at is we can count the vanishing points, right? So if an image has one vanishing point, that's a 1-point perspective. 2 vanishing points is a 2-point perspective. 3 vanishing points is a 3-point perspective, and so on and so on and so on. Okay, so when we look for perspective, when we're trying to identify what perspective we're looking at, we're just counting the vanishing points. Okay, so for this one, count the vanishing points. Count the vanishing points. All right. I hope you guys enjoyed the class. Any work that you have to turn it in by the last day that the final is posted. So get me your work before you do the final. Any extra credits you want to do, I'll still accept it. Even if you want to do a short movie or short essay on a movie that you've seen outside of class, I'll take all of it. All of it. And you guys, I've really enjoyed watching your project. Some of you guys took it and just really blew my mind. So good luck, and I enjoyed the quarter. Also, there's a film club on campus that I have, so hit me up if you want to be part of the film club, and also a film festival. And in the film festival, I need students to screen short films from all around the world and vote on them if we want them in or out of the festival, right? That's simple. All right, so Professor Paul, over and out. Check out my class next quarter. Hopefully it should be screenwriting. So all you screenwriters out there who think you may have a story and you're crazy enough to dive into writing it into a movie, I'm on campus. All right, peace.